Okay, so we're gonna start with our new unit, which is exponential relations. And the first thing that we're gonna do with exponential relations is going over the exponent law. You should have seen some of these in the previous courses, and you should remember them as we go. But we're gonna discover them anyway together, and then you're gonna have to use them again in grade 12C. So if you're taking grade 12C, you're gonna see this topic again. Grade 12 college. Okay, so the first thing that we're going to do here is we're going to look at exponent law, and then we're going to develop the multiplication law. Okay, so if I'm going to look at a4 times a to the power of 5, so a to the power of 4 times a to the power of 5. If I want to expand this, it's the same thing as saying I have a times a times a times a, right? That belongs to the a to the power of 4. And then I have multiplication, so times. And then I have another a times a times a times a, which belongs to the a to the power of 5. So altogether, how many a's do I have multiplied together? 9. So that's the same thing as writing a to the power of 9, right? Now, my second one is a to the power of 2 times a to the 4. Okay, so I have a times a, and then I have times a times a times a times a. So I have 6 a's multiplied together, which is a to the power of 6. How about the next one? What do I do? Times a, that belongs to the a by itself, so that gives me a to the power of 6. And then I have for a to the power of 6 times a to the power of 2, so I have a times a times a times a times a times a, 6, and then I have times a, which is a to the power of 8. Do you see any pattern here? Add the exponent, right? It's the same thing as simple as if I do 4 plus 5, that gives me 9, right? If I do 2 plus 4, that gives me 6. If I do 5 plus 1, that gives me 6, right? So what's happening here, because it's the multiplication, and then a to the power of 2 is already multiplication, a times a. What happens is you are basically adding your exponent. Now this would work if you have the same base. You must have the same base for this to work, right? So you see that all what I have here is a's multiplied together. Okay, so what will be the answer for this one? A to the power of 7. Okay, so for the multiplication law, we keep the base, so you must have the same base, right? So you're going to keep the like base. So you see nothing is changing with the base. It stays the same. And add the exponent. So for example, if I have a to the power of m times a to the power of n, that's a to the power of m plus n. Okay? Important is I have the same base, it's not changing. Are we okay with this? Now moving on to the division law. So if I'm dividing a to the power of 5 divided by a to the power of 4, right? So again, I can expand, and a to the power of 5 is a times a times a times a 5 times, right? Divided by a to the power of 4, which is a times a times a times a. Now when we have division, we simplify, right? Especially if we have the multiplication, right? I can simplify this by this, this by this, this by this, this by this, right? What am I left with? A. A to the power of 1 or A, right? Now if I do A to the power of 4 divided by A to the power of 2, that's A times A times A times A over A times A. And now I can cancel them. One from the top, one from the bottom, one from the top, one from the bottom. And I'll be left with A to the power of 2. How about the next one? What would my answer be? A to the power of 4. And why is it A to the power of 4? What's happening here?
Canceling 1A with 5.
With a 5 on the top, right? So if I have 5 A's on the top, and then I have 1A at the bottom, I cancel 1, so I'll be A to the power of 4. Do you see a pattern here? What is it? Subtracting the exponent, right? So if I do 5 minus 4, that gives me 1. If I do 4 minus 2, that gives me 2. 5 minus 1, that's 4, right? Now 6 minus 2, so it's going to be A to the power of 4, right? Because what I do is A to the power of 6 minus 2, which gives me A to the power of 4. Next one. It's going to be A, because A to the power of 4 minus 3, that's going to give me A. Okay? Technically, I won't be expanding. We're just doing the expanding so we show you why this is happening. Okay? We're going to be doing mostly right away using the exponent law. So, for the division law, you're going to keep the same base or the like base. And then subtract exponents. And I have, if I have A to the power of m divided by A to the power of n, it's going to be A to the power of m minus n. We're good with that? And we're moving on to the power of the power law. Okay, so with the power to the power law, I have a base to the power of a number, and then again to the power of another number. So I have one base, which is, for in this case, it's A, to the power of 4, and then to the power of 5. Okay, so if you look at this, A to the power of 4 to the power of 5, that means I have A to the power of 4 multiplied 5 times by itself, right? So that's A to the power of 4 times 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 A to the power of 4. Now what did we learn from the multiplication law? What do I do with the multiplication? Add the exponent. So if I'm going to now come and add this exponent, 4 plus 4 plus 4 plus 4 plus 4, I'm going to get 20. But if I want to, like, do it fast, what would I do? 4 times 5, right? So even if I do this one, right, it's going to be A squared times A squared times A squared. If I add my exponent, 2 plus 2 plus 2 is 6. So that's A to the power of 6. But I can technically multiply 2 times 3. Yes? This is power to the power. So when you have power to the power, you multiply your exponents. Okay? So A to the power of 5 to the power of 2, that's the same thing as doing A to the power of 5 times 2, which is A to the power of 10. Okay? A to the power of 6 to the power of 3, That's the same thing as doing a to the power of 6 times 3, which is a to the power of 18. Now, yes, you can show it, right? But we're not going to be doing that once we learn our laws, right? The reason we're doing that is to understand why the law. Why, when I have power to the power, I multiply. Or why, when I have multiplication, I add the exponent. That's the reason we're doing the expanding. We're not going to be doing it when we're solving. What will be the answer for the last one? A to the power of 12. Okay? So when I have power to the power, I keep the base. And then multiply the exponents. So in this case, I only have one base, yeah? So m to the power of n is equal to am times n. Are we good with that? What will be the answer for the first? X to the power of 11. What am I doing to the exponent? Adding them. Perfect. 8 plus 3 is 11. Keep the same base. Okay. How about the second one? X to the power of 8, because I am multiplying the exponent. Okay. X to the power of 6. What am I doing to the exponent? Subtracting. So 9 take away 3. How about for the next one?
Could be x to the power of 4 and y to the power of 10. Would you keep them in brackets?
Doesn't matter at this point if you keep them.
Y to the power of 7.
Y to the power of 7. Yeah. Yes, it's 1 because it's not, the 5 is only to the y here, okay? So that's going to be, this exponent right here is 1, right? So I'm going to add the exponent. So it's going to be x to the power of 4. And then y to the power of 7. Are we okay with that? Okay, how about for the next one?
X to the power of 24.
Be careful there.
I know.
X to the power of 10, because I have the x and the 6, I'm going to add them because I have the multiplication law, right? So that's going to be x to the power of 10, y to the power of 3. It doesn't change, right? Because the one that I'm multiplying with is x, right? I'm looking at the same base. I'm going to write this one as a division, okay, as a fraction instead of writing it as a division. So I'm going to write it like this. This is too sensitive today. Okay, tell me what you would do.
My answer is 2x y to the power of
2x times y to the power of 3, right? Yes. The 2, there is no other number that I can simplify it with, so I'm going to have to keep it. The x's together, if I subtract my exponent, 7 minus 6, that's x to the power of 1, which I don't have to write that power of 1. And then the y, if I subtract my exponent, it's going to be y to the power of 3, because 4 minus 1 is 3. We're good? All right. Now that brings us to the power of a product law. Okay? Now let's understand what these words mean. Power means exponent. Product means
Result.
product means what operation is plot? Multiplication. So I have the power of a multiplication. So there's a multiplication happening, but then there is a power on the outside. Okay? Eyes on the board for a second, please. So you see that the power is the 2 outside, yes? Okay? And the product, there is a product happening between x to the power of 4 and y to the power of 3. There is a multiplication happening there. Now, can I simplify inside the bracket? No, because they're different base. Okay? They're not the same base, so I can't simplify them. Now, what happened here, because it's a power of a product, that 2 is going to affect both terms inside the bracket. Okay? So, power to the power, I have to multiply. So basically, I'm going to multiply the 4 by the 2 and the 3 by the 2. Right? So that's going to be x to the power of 8, y to the power of 6, and that's my final answer. Okay? That power, because I have a product in the middle, inside the bracket, that power is going to affect every single term inside the bracket. Okay? How about if I have something like this? What do you guys think? Does it?
I think so.
I think so too, right? Because technically speaking, right, this is the same thing as writing 3x squared y4 times 3x squared y4, yes? And then if I want to simplify this, I have to multiply the 3 by the 3 because there's a multiplication there, right? And then I have to take the x and then add the exponent, take the y and add the exponent, yes? So the most common mistake that students do, they forget to bring that square to the 3 as well. If it helps you, eyes on me, if it helps you, put a 1 on the 3 as well, because that technically has an exponent of 1, right? It has an exponent of 1. If it's 3 by itself, it's an exponent of 1. So then distribute that 2 in. So that's going to be 3 to the power of 2, which is 9, x to the power of 4, y to the power of 8, which is going to simplify to 9, y4, x4, y8. Okay? If it helps you. If you guys understand that you also have to raise that 3 to the power of 2 right away, you don't have to do that extra middle step. Okay? So this is the power of product. Now we're going to take the power of quotient. Quotient means division. Okay? So I have a division inside the bracket, and I have a power that's outside that's going to apply to it. That's the same thing as writing this, yeah? Yes? Okay? So basically same thing. That 2 is going to apply to every single term inside the bracket. So that's going to be x to the power of 8 over y to the power of 6. Okay? Power to the power. Again, power to the power. Multiply. I would do that first, yes. So if I have, for example, this. Let's see. Yeah, this is what you're asking. If I have this. BEDMAS says simplify inside the bracket first, right? So I would simplify inside the bracket first. Then I would bring my 2 in. Now, it doesn't make any difference if you bring the 3 in first. It doesn't make any difference. You can do either. But would you want to distribute that 3 or would you want to simplify inside first? I would personally simplify inside and subtract my exponent, right, which is going to give me x to the power of 2, and then multiply. Okay, if that was me. If you guys want to do x to the power of 12 over x to the power of 6 and then subtract, it's the same thing, right? It's going to give you the same answer. So at the end of the day, it doesn't matter which way you follow. The less terms you have, the better it is. Okay? Okay, how about the power of sum or difference? Same what?
You multiply the 2 by the 4 and then 2 by the 3. Plus, it's the same as what you said.
Okay, let's go back here for a second. Expand this for me.
X minus 2, x minus 2.
Okay, so you had to write it twice, yeah? And then what did you have to do? FOIL, right? FOIL. So x times x is x squared. X times negative 2 is negative 2x. Negative 2x. And then plus 4, which is ending up with x squared minus 4x plus 4. If you were to distribute that square in, are you going to end up with this? What are you going to end up with?
X squared
Plus 4.
plus 4.
Okay, is that right? No. So when you have sum and difference of the terms, you cannot bring the power in. You have to expand by FOIL. Okay? So this doesn't follow the same rules as what we did on top, where we just multiply the exponent in. This one, we have to actually write this twice. And then we have to FOIL. So let's FOIL. What's x to the power of 4 times x to the power of 4? No. So I'm going to have to do x to the power of 4 times x to the power of 4, which gives me x to the power of 8, because I add my exponent when I'm multiplying. Okay, what's x to the power of 4 times negative y cubed?
X to the power of 4 and y 3.
So it's going to be negative x to the power of 4 times y to the power of 3. How about negative y to the power of 3 times x to the power of 4? Doesn't matter if I write x first and then y second? It doesn't, because it's multiplication, right? So x to the power of 4, y to the power of 3. And then, what's negative y cubed times negative y cubed? Plus, because negative times negative is positive, y, if I add my exponent, it's going to be 6. Are we okay with this? So we're putting it all together. Now, if I'm going to collect like terms, do I have any like terms?
Yes.
What are they?
Negative x.
Negative x4y cubed and negative x4y cubed, which gives me?
Negative x and y. No.
Okay, question for you. If you have negative x minus x, what do you get?
2x.
Negative 2x, yeah? Negative 2x. What if you have negative x4y cubed minus x4y cubed?
Negative 2x.
Eh? Because I'm adding the coefficient.
Wouldn't there be a 2 in front of the y as well?
No, 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 because they're multiplied. They're like, this is a package. This is negative 1 x4y cubed minus 1 x4y cubed. They're together, right? So you have only one coefficient there. Okay, what are we confused about?
Okay, so it was negative x for y3 and negative x for y3. Why didn't you just leave it for 3? Like, shouldn't it be no exponent? Or like if you are, then be like.
Well, when you're adding these two, that's negative x minus x. What do you get?
Negative 2.
Negative 2x, right?
Yeah.
What if you have x squared plus 5x squared? What do you get?
6
6 what?
x.
Squared. Because you're adding them, right? If I have 5 apples plus an apple, that's 6 apples. It's still apples. It doesn't change. It doesn't become bananas, right? So when I'm adding, I'm just adding the coefficients. They have to be like terms, and I add the coefficient and I leave the term as is.
So you're not going to touch the 4y3.
No. Okay? I'm just adding the like terms. I'm adding their coefficient. When you're multiplying, then you add the exponent. So if I had this, for example, so that's x squared times 5x squared, then that's going to be 5x to the power of 4 because I'm adding my exponents. Okay? But when I'm adding the terms, I just add the coefficients. Okay?